Can you see my screen share?
I can.
Good. Is everyone in, Elaine?
Just a few on their way, Julia. Yeah, I think that's it.
Lovely. There we are, spot on 5 o'clock. So welcome everyone. Thank you for joining us for our monthly Twilight Talk. We've got a super subject and a super speaker for you tonight. My name is Julia Bennett. I'm a director of the Green Register, and I'd like to introduce my colleague Elaine, who helps keep everything moving smoothly, and she would have sent you out all of your information. I'm just going to give you a couple of slides just to tell you about some events that are coming up. If I can find my intros. There we go. So hot off the press, literally, is all the information for next month's Twilight Talk, which will all be all about the difficulties that we all face when we're trying to specify truly sustainable products. And what we've got is a very informative speaker called Alex Watson, who's been looking at how we can use mechanisms for border carbon taxing to make sure that UK locally produced, truly sustainable products are not being pushed out of the market by not so net zero, green, carbon friendly products from other countries. And then we'll have 3 product presentations. So one of them is K-Bricks that you might have heard of, an initiative from Heriot-Watt University in Scotland using recycled materials. Hemp cladding panels, so a nice new product that is very viable for external cladding. And many of you will be familiar with Medite Smart Ply, and they're going to give us a summary of their latest sustainable timber board products. We can get right down into the nitty gritty and you can ask them lots of questions. So that's 5 till 6 p.m. next month, Monday, the 10th of July, and it's free as always for a Twilight Talk. But here we are, this very evening. I'd like to introduce Mark Colyer, who is a director of Scantherm Surveys. He is, I don't think there's a thing about thermography that Mark doesn't know. And if there is, then very few people know it. I've had the privilege of being on one of Mark's training courses. And I hope that during the course of this evening, you'll understand that it's simply not point and click, and so much more than that. And the subtleties of what you can get out of thermography are absolutely fascinating. So with no more ado, I'm going to stop sharing my screen and welcome Mark Colyer. Hi there, Mark. Let's see if your screen's going to share. Hi.
Thank you very much for that intro. Can you see my screen okay?
We can indeed.
Okay, good. Well, thank you, Julia and Green Register, and good afternoon, everybody. I appreciate you calling in on this baking evening when you'd probably prefer to be on a beach, or if you weren't on that, the next best thing might be a seminar solely related to reducing overheating, because I'm sitting here in 29 degrees and many of you probably are too. Obviously, thermal imaging can help on that. I just haven't done it on this building. So, quick introduction, Scantherm, we provide thermal imaging and associated building diagnostics. Our specialism really is in building fabric analysis. So we provide surveys, we provide training and applied building thermography. It's very unique, it's very practical, and also consultancy in any aspect of building thermography in terms of project specification, expert technical advice, consulting, and so on. I'm not going to go through all these, but many of our clients are big, many of them are small, public and private sector. I'll talk about one, talk about me firstly. My name's Mark. I'm actually a mechanical engineer turned thermographer. My first thermographic experience, I'm aging myself, if my hairline didn't already do it. My first thermographic experience was in 1987 in another world, in the automotive industry, in fact. But since 2008, I've been solely focused on building thermography. I founded Scantherm in 2008. and really had 100% focus on building fabric and systems ever since. A long story I won't go through with you. I got involved in developing building thermography training in 2010 for one of the major camera manufacturers, and that was through a company in Germany. And then in 2014, we launched ScanTherm brand of this thermography, really fine-tuned for English construction. And I will say English, I guess it covers UK to a certain extent, but it's more England than, let's say, Scotland. But I'm still doing an awful lot of surveying, hands-on, hundreds per year. We're, more surveyors than trainers, let's put it that way. So notable project, one of the biggest projects I've been involved in the last couple of, the last 4 years, it has been around the Palace of Westminster on the R&R project. So that's the back of my head, up by the House of Lords on a roof. In fact, over the last 5 years, I think I've surveyed lots of buildings around Westminster, all the buildings highlighted here, which I guess has probably been the most interesting and in many ways the most challenging project I've been involved in. So, agenda. I'm going to go through some basics about what thermography, building thermography is, why we would use it, what some of the key benefits are, some of the important factors in terms of planning and doing building thermography. I'm going to talk about who can do it. It's a kind of contentious subject, possibly, but I think I'm going to try and grasp the nettle on that. And then I'm going to go through some case studies on a range of applications, looking at building heat loss, structural water leaks, flat roof leaks, some slightly more esoteric structural investigations. I'm going to try and answer the question, is it an art? Is it just like a normal camera point and shoot? Or is it a science? And then hopefully, if I don't ramble on too long, I'll have some Q&A. So without further ado, let's go through some basics. So what is thermal imaging all about? Well, we've got a photograph here, a normal daylight photograph of a house. And if we use a thermal camera, then we end up with an image that looks something like this. So on the surface of it, it's very similar to a photograph, just some pretty funny looking colors. Why, and my screen's just died, now it's come back. Why would we use thermal imaging on this building or many others? Firstly, it's obviously all about sustainability, because we can use thermal imaging for visualizing heat flow through the building fabric, and then deducing what we can deduce from that. That leads potentially, hopefully, to reducing energy consumption. We can also use it for looking at moisture in buildings. Damp buildings tend to be cold buildings or hot buildings in this weather. So we can use it to find damp trace leaks. We can also use it for locating hidden, I'm going to call it stuff. So structure, systems, and other things that are otherwise buried within the building. And some of those and some other things, we can use it for monitoring and diagnosing systems. So whether that's renewable systems like solar panels, or whether it's heating, ventilation systems, underfloor heating, and so on. I'm not going to talk much about that because I've really only got a limited time. I'm going to focus more on the fabric, but there's large opportunity out there for doing systems analysis as well. So the key benefits when we think about thermal imaging in buildings are that, number one, it's non-contact. So I can often do it from a distance. I can often do it without access equipment that might be required for other methods. And it's also non-destructive. So it's quiet, it's safe, it's clean, and it doesn't need need rebuilding after you've started digging holes. So what is a thermal image? I've got 3 examples here, which in fact is one thermal image presented 3 different ways. So a thermal image is a visual, let's say, map or representation of radiated infrared energy. And I guess my first real learning point for today is that despite the fact that you can see a temperature scale on here, and often you'll look at images and there'll be areas and points and lines and all sorts of stuff all over it showing measurements, a thermal camera does not actually measure true thermodynamic temperature any more than a moisture meter measures moisture in buildings. It's an indirect method of trying to either measure or approximate temperatures, but you need to give a whole load of other information to the device before it will come up with a potentially sensible indication of temperature. So it's actually showing us radiated infrared energy. Now, the 3 images on your right are what we call palettes. There are many palettes, many more than this, but probably the most common are the rainbow high contrast at the top. Iron bow is another common one. This black and white grayscale one is also another one. And again, I could spend at least the whole hour talking about what the benefits are and why you might want to use different ones. In short, generally speaking, most of the time, rainbow high contrast is probably the most useful for building thermography, and all the images I think you're going to see moving through the rest of this session are going to be in rainbow high contrast. Another key learning point to take away is never to believe or believe anyone that tells you that thermography, thermal imaging can see through buildings. It cannot see through any normal building materials at all. So the common question is, oh, I want you to find this, it's so deep in the floor, how deep can you see? The answer is, which tends to disappoint people, is not one atom. It's a surface technology. It's measuring radiation on the surface and nothing else. Now, depending on the circumstances, it gives the impression of seeing through the building and showing what's buried within a wall or below a floor or in a roof. But don't kid yourself, it's not seeing below the surface. So what do the colours mean? I'm going to just take an example here, typical UK heat loss application. So if a building is heated inside and it's scanned when it's cold, when there's no solar load on it and so on, then when we look on the outside of a building like this, in the most simple terms, when we're looking outside, the hotter colors in this rainbow image, so the yellow and the red colors, simplifying it almost too much, we can say these are generally the bad news on the outside. And when we look on the inside of the building, so this is looking at a ceiling inside the building, now the cold colors under the same conditions when it's cold outside and warm inside, the colder colors, the blue, this funny pinky color, and the black, these are essentially the bad news on the inside. So at its most simple level, that's how you do thermal imaging. And I guess that makes it look pretty easy, yeah? Can't, you know, how hard can it be? Well, it is a bit more complicated that. So if we look at another building taken under normal heat loss conditions, and we start looking at it, we can start seeing there's quite a lot of stuff going on, not least the fact there's half the post office tower or whatever it's called these days seems to be floating in the sky above it. We've got to look at and question, when was the image taken? What were the conditions inside and outside? What's the construction type? What sort of materials? And the reason we have to ask that is because many building materials, such as glass, metals, and others, they reflect infrared energy in different ways and behave differently in infrared wavelengths and they can lead to very confusing images, such as you get on this building. So yes, we can do red outside is bad news, blue inside is bad news. We can look at things simply, but really to fully analyze thermal images, there's an awful lot more knowledge required. Some things are reasonably intuitive, many are not. So what kind of buildings can we look at? Well, pretty much anything really. So we can start small. So we can look, I don't know if you can see here, this is a light hanging from a ceiling. I'm looking through a doorway into a very cold bedroom here. We're looking at the ceiling. And well, you can see a little bit of insulation here. Unfortunately, you can't see much. I don't know. Can you see my pointer, by the way, Julia? Do you see my pointer?
Yes, very clearly.
Oh, yeah, thank you. So yeah, so we can see a little bit of random insulation that appears to be here by mistake, but the rest of the ceiling is uninsulated. We can move from that to huge buildings. So this is part, I think, of the University of Westminster, an absolutely massive building up on Marylebone Road. Anything between. We can use thermal imaging inside, we can use it outside. Normally, we're going to do some of both. We can look at historic buildings, inefficient historic buildings, or we can look at very efficient, maybe non-traditional construction methods, new builds. And if you're looking at that building going, I don't quite understand that image, if that helps you, yes, it is a rather unusual building. But the bottom line is there's no rules where you can and can't use thermal imaging. If you go about it the right way, if you understand the physics of what's going on and you understand the limitations of the technology, then it's universal, let's say it that way. So let's look at some of the important considerations for any building thermography project. Number one, planning. Planning, asking questions, and then more planning is absolutely fundamental to going about doing a building survey. And once more, I'm showing my age here, so any of you who were around here, I think it was 1987, know the value of weather forecasts, but we do need to use weather forecasts. We need to plan round them. We need to read through them and beyond them. We need to look at building orientation. We need to look at where the sun's going to be and think about the times of the day and the days of the year. And the survey conditions that we need are fundamentally different for many types of applications. So looking for moisture in the roof of a commercial building is fundamentally different from looking at the insulation properties of the wall of an industrial unit, for example. And it's a key area of know-how for building thermographers to know what you need and what combination of parameters you need for any particular survey. So another key consideration based around planning is understanding what is desirable and what is feasible, because what a client needs isn't always what can be done. And so juggling that and finding the right compromise is essential. Another kind of principle of building thermography, which applies in many circumstances, not in all, excuse me, let's try and get rid of that phone call, so I'm probably talking to someone now inadvertently. They're getting a free seminar. Elevation can be useful, so in some cases critical. So if we're looking at this building and we want to do a roof survey, when I talk about elevation, many of you might be immediately thinking of drones, but in fact a mast, 25-meter mast on a vehicle, or a smaller mast that can be hand moved is often very, very useful for looking down and getting a different perspective of certain parts of buildings. But coming on to drones, again, when we're looking at large, let's say tall buildings, large roofs, large estates, places where access is either difficult or dangerous, then a drone can be very useful and cost effective to get this kind of view around a building. We've got a custom solution here, flying a high-end, quite heavy handheld camera under a large, stable drone, but ideal for flying around central London, middle of the night, for example. Another thing, when we're looking specifically at heat loss from buildings, is to consider pressurization of the building, usually negative pressurization, but using a blower door as used for air permeability is often incredibly insightful and provides a very robust method of gaining a really, I hate the word, but I'm going to use it, holistic and realistic understanding of actual heat loss mechanisms from any given building. So I won't mention the house builder, but this is a new build from one of the major house builders. It probably could be any of them. And when you do when this survey started, you're getting a bit of a hint of something going on just under the ceiling up here. But after some depressurization, this in fact, I came back right at the end of the survey, an hour later, and what in that hour, the air temperature in this particular room has probably fallen by about 3 degrees. The wall temperature has dropped down in places to probably about 12 degrees below dew point. And sorry, got rid of that. And you're getting a fundamentally different picture of the building, and in this case, thermal bypass, pretty much negating the performance of the insulation, which is probably installed to specification in the wall, but the building as built isn't performing. So depressurization, very valuable. So coming on to who can do thermography. Anyone can do it, right? Well, actually, the answer is yes. Waving a cheap camera around is very easy and it's very, very cheap. But I think someone who employs, I hope this guy hasn't called into the, called in, so nothing personal intended, but whoever might employ this guy, I think might decide that choosing him could have been a liability. Anyone who's got to pick up the pieces after using a survey from this fella may disagree. So that leads to the question, well, who should be doing building thermography? So let's talk a little bit about certification. And again, I could talk for an hour or more just on certification. Generally speaking, building thermography is completely unregulated, other than for BREEAM schemes, where most BREEAM schemes require a thermographer certified to level 2 or Cat 2 or class 2, depending where you look. Other than that, anyone can offer any service to anyone with any equipment. And that's not really a great situation. And so identifying competency is an ongoing concern for the industry. And competency is really much more than just showing a training certificate or talking lots of pseudoscience and confusing you. And it's a problem. There isn't, I can't give you a quick answer to it. So what does it take? And I'm not going to go through this slide word by word, but I think any survey really needs a basic understanding of the technology and its limitations. And you need to understand your own limitations. And of course, you need domain knowledge. You've got to know something about construction, and the more you know, the better. Moving from, if you like, the minimum to a successful professional survey, this requires very realistic expectations. It requires capability and discipline to plan and prepare appropriately. It needs a full knowledge of technology and its limitations, of building physics, ability to assess risks, and probably, you know, one of the most important things, it really requires the ability to analyze images and identify what is important. Because any thermal image you look at, the more you look at it, you will find more and more and more in there, and you've got to work out what's important and what's relevant, and what's maybe just the way things are, and it's not going to, doesn't answer the goal of the survey. So that's my list. Others might have other views, but I think that's really what it takes. Quick look at equipment. You can buy really a cheap add-on device, plug into your camera for a few £100, or you can spend tens of thousands, 20, 30,000 pounds on a good professional camera. Is there a difference? Absolutely. For sure there is, but it's beyond this introduction to go through the differences. There is a difference. Is this kind of, I'm going to call it rudely, hobbyist equipment? Is it a waste? No, not necessarily. I don't think it is a waste. So what do you need? Well, the answer has got to be it depends. It really depends what you're trying to achieve. But my real message is, we can all get snobby, me included, about having really good professional equipment. And yes, you can work faster, you can work better, you can do an awful lot more with it. But I wouldn't knock some of this. If you know what you're doing with it and you know its limitations, they are useful. You can check a bit of ceiling insulation, you can find an underfloor heating system. You can do really useful things very cheaply. So I'm a fan of the cheap equipment as well as the expensive equipment, as long as you know its limitations. So this is the difficult one, difficult one for me. Can you do it yourself? I've got to take a or we've got, I and everyone, I think we've got to take a reality check. There is an ongoing need for householder and community engagement. And I'm sure there's many people in the seminar who are in this position. So can you DIY it? So this is me beginning to sweat, because what am I going to say? I'm going to grasp the nettle and say maybe, to some extent. I think the key is that there has got to be some basic training. Using a camera, whether it's your £100 camera or your £20,000 camera, what's more important is what you know, and knowing your limitations and knowing the limitations of the technology and where it might be misleading you. You've also got to be able to consider and clarify the liability. So if you're doing it for yourself, looking at your own house, that's very different from if you're charging someone or hiring equipment to someone for them to then go and you're going to convince them that they're capable of doing it. So it's got to be done with eyes open. So there is a big gulf from DIY to a carefully managed scientific process. So flying a high-end camera on a drone around a tower block on the Isle of Dogs is different from going in and looking at your neighbor's ceiling. Those are two different things, and I recognize that. And I would say that if you do it thoughtfully with some level of understanding, then it's probably better done than using this guy who's going to try and convince you with his pseudoscience thing. So done with caution. I wouldn't say don't DIY, as long as you cover the bases. So moving on to some case studies, looking at heat loss first. By By far, I think the most common application is insulation and thermal bridging. This is a typical situation prior to looking at refurbing some social housing. So here's a photograph taken after the survey was done in the early hours prior. When we take a thermal image of this building, we get something like this. And when we look at this, what we can see straight away is a lot of thermal bridging across the building from floor slabs and structure. So we've got repeating thermal bridges all over. And these thermal bridges get a lot worse around bridges. Around balconies. And then when we look harder, we can also see that probably decades ago, the building has had some kind of cavity insulation installed. So we can see voids here compared with a better fill here or a better fill here. And then there's another big void here when we compare it with other areas of the wall here. And then the more we look, we see these kinds of voids. So this is a very typical starting point to a major refurbishment of a 1960s maybe typical UK construction. Slightly different approach this. This was a bit of a shocking one. The building had already been block of flats down on the south coast had been upgraded. Someone, possibly a cavity wall insulation installer, had specified cavity wall insulation, and I was brought in by a firm of surveyors who had been brought in the following winter after the insulation was installed to look at why certain flats had started getting damp spotting across the building. Now this was I was approached to do this, I think it was in May, but we actually found a really cold morning, and we could only scan the north facing elevation. So this was by going down very early in the morning. So it's not the greatest image in the world, but it did the job, because when we scan it, if you see this line going across the back of the building, that's essentially the line of cavity wall fill, and everywhere above has not been filled. And this, you can't see the bottom. We're looking over some trees here. I can't remember. I think it's about 7 stories in total, the height. So this particular insulation is only specified, I believe, up to 12-meter height, and it was a completely inappropriate application. But where you have this partial fill, you then start getting all sorts of other problems and so on. So do it before retrofit, but here's an example of why you might want to do it after retrofit as well. Coming back to air permeability, this was quite a complex building with, I think it was the first and possibly only building I've ever surveyed that had active insulation. And I won't try and explain that. If you know what that is, I'm sure there's lots of people who do. I was worried before I did the survey. And after I did the survey, I called a certain Mr. Jennings. I don't know if he's in the call, and asked him to come and assist me. And when he came along and put his blower door on it, and we went to town. This was actually done during the summer as well. Really heated the building and went in the middle of a cold night. And what we were looking for here, fine, the air permeability was one thing, but looking at the air leakage paths through this building was what we really needed to do to understand what was going on. So here's another example in this case on a commercial building where combining air permeability and thermal imaging is very valuable. This was a building that was meant to have been built to passive house standards. It wasn't the owners, from memory, had decided not to go the whole way and actually get it certified. And I don't know exactly what did and didn't happen along the way. Again, I think Paul Jennings was involved in this and may know more of the story, but I did the thermographics on it. And this is not built to passive house or anywhere near passive house built standard. So just quickly, very drafty around the door. This roof area here has possibly is insulated, but it's clearly got thermal bypass. We've got air intrusion here. We've got temperatures down to even the air, though the air temperature in the building was, give or take, let's say 20 degrees C. We've got surfaces here have dropped to 7 degrees. Yeah, and this is meant to have been a passive house. And we've got air intrusion into the internal wall systems here, and off it went round the house. Utter disaster. So moving on, keeping an eye on the time, looking at moisture in buildings. So completely different one here. This was the basement of a new build school. So this was their Muga, their multi-use games area. And I think it was about 1 year, possibly, after the building was handed over, they noticed some, I don't know how, I hope it's coming through okay on your screens, but they noticed on some of the lower areas of this wall, some water damage along the bottom of the wall here. And then a little bit later, they started noticing some buckling of this very expensive activity sports floor. And they had suspicions that it related to, there was the school plant room was the other side of this wall here. And they thought there must be potentially a leak. There was no underfloor heating in this area. These are all, I think, panel heaters of some sort. And as I say, this is a basement, certainly a partial basement. It's mainly basement. And so anyway, this very quick scan later, looking at the end of the wall thermally, we can see here where the plant room is. So there's a load of heat loss coming through, sorry, a load of heat loss, a load of heat transfer coming through through the wall from there. But when we look at the base of the wall, there is some kind of anomaly here. But as you look along, the anomaly seems to be getting stronger, moving around this way. So with more thermal scans, as we come around the building, suddenly we start seeing an anomaly. And thermographers use the word anomaly a lot. It doesn't necessarily mean fault, but it means something we're not expecting to see, and that's very much a thermal anomaly. And then moving on a bit further, there was a second thermal anomaly. And again, I don't know how well you can see, but this is looking at the wall around this second one. When we look closely, we're led in and start seeing a bit of staining on the skirting at the bottom of the wall here. I don't know if you can, hopefully you can see that. So a load of thermography, a load of moisture mapping and so on later, we drew conclusions saying we believe that we're quite precise where we thought the leaks were, and basically it was a breakdown of the tanking, the waterproofing, or I think it's waterproof concrete, and said it needed to be opened up. And by chance, this was one school holiday, and we had to go back the following school holiday to look at some roof leaks. And while we were there, the main contractor who we were working for said, oh, while you're here looking at the roof, you might want to come down to the basement because we're just opening up where you told us to. So I went down and looked, and lo and behold, where they opened up, here we can see the water ingress through the concrete basement structure. And looking at it thermally. So sometimes we don't get an outcome quite as precise as this. We rule a lot of things out, but other times it can be very, very valuable for non-intrusively pointing in the right direction for potentially very significant structural leaks. Again, keeping moving quickly, locating moisture in flat roofs. Here's a typical aging flat roof, and I have to say, I've always thought this particular survey was a bit pointless because we were told the roof was not structurally sound, so we couldn't go on it, which maybe told the answer in itself. But anyway, they wanted to prove that the roof was leaking and that would therefore need replacing. So this is done on a summer's evening. You can see, yes, we've got a bit of standing water and moss and rubbish debris here and here and here, but thermographically we're seeing something completely different. We're seeing where we've got wet insulation basically from end to end of the roof. There's a load of other stuff going on which I won't talk about, but this shows the extent of the moisture intrusion and helps justify the actions required. Final case study. This is going a bit off piste. It's a completely different one. This is a grade 2. It was once upon a time a farm building, which is actually owned by a university, and it had been used very unwisely as student residential accommodation. And rumor has it that a party occurred in the house, and I don't know, 50 or 100 people decided to start pogoing or dancing on the first floor, and it started collapsing. So when I was brought in, the building had been essentially been condemned. I was working with structural engineers. There were acros all around it, holding it together. And the problem was that because it was grade 2 listed, the heritage officer would not let the structural engineers examine the wooden frame. So the goal was they wanted to try and find the timber frame without any intrusion. So they asked if it could be done. We found some methods of doing it. So this is actually the deliverable. The deliverable was to draw the frame right the way around the building on the wall. And the way we did that was from thermal images like this, where we created heat flow from room to room. And this is what, going right back to one of the very first slides where I said you can't see through buildings, but a lot of people believe you can see through the buildings like an X-ray with thermal imaging. And this, by the way, is a grayscale image. I said everything was going to be rainbow high contrast palette. I lied to you, I'm sorry. This one's grayscale. In some cases, different palettes have more use, and in this one, this was more use. So we can see where the fireplace has been blocked up, and then we can see the timbers. And what that allowed the structural engineers to do was then to go and work with the heritage officer to say, we want to make some small holes now. We know precisely where to minimize the damage and examine what's happening with the timber frame. So, is it an art or is it science? Am I going to sit on the fence? No, it hurts. I came across this once and thought it was, I thought it was quite a useful statement. So at their core, art and science are both about observation and interpretation. And thermal imaging, building thermography, is most definitely about science. It's about building science, it's about thermodynamics. But I think it's also, there are many skills involved which you could call an art. So designing a practical project within real world constraints, there's an art to that. Taking useful images, composing images well, there's a bit of art involved, I think, in that, telling the right story. And interpretation. Yes, it's about observation and it's about interpretation. And image analysis may be about measurement, but many times in building thermography, it's about qualitative interpretation. And there is some art to that as well as science. So without being too philosophical, it's both. It is art and it is science. So to finish, ScanTherm training, it's unbiased, I would say. I've got no axe to grind in any one particular direction. We provide full user training through open courses or in-house courses. Quick sales, the next 3-day applied building thermography, which is designed for complete newbies to building thermography, or people that have been through the traditional level 1, level 2 and found it didn't teach them anything at all about building thermography. The last course I ran last month, I had a level 2, I've had a level 3 before, which is the highest level training you can get in thermography. This is very different. It sits alongside, or I would say in front of, level training if you really want to know about building thermography. And we do CPD in-house for large companies or organizations, and I've done it in the past for REBA, CIOB, RICS, etc. You'll find more details there at scantherm.co.uk. And so that just is down for me to say thank you for listening. There's my contact details, and I think, Julia, you're going to take over Q&A.
I will indeed. I'll give you some help in picking up some of the points that have been raised in the. So if you would like to stop sharing, and we'll let people be able to see you a bit more. So one of the first questions is from Laura, who was saying, cameras can be either cheap or expensive, as you've said, but do they need to be calibrated and set up in any way? And I said very quickly, the simple answer is yes, but I'm going to let Mark tell you a bit more about that, because I remember some of the detail from the course, but not all of it. So what are the things that we have to be aware of when we're setting up an IR camera?
So 2 things. Setting up and calibration, I think, are 2 different things. Calibration, it depends what you're doing. So if you are doing wholly qualitative, sorry, I get word blind between qualitative and quantitative. I know what they mean, but I sometimes say them wrong. If you are doing qualitative assessment, which much of building thermography is, calibration in itself is not going to add a huge amount of value. If the camera is broken, you'll probably know that. If it's grossly, there are some basic ways you can do a self-calibration, which is partly maybe what Julia's remembering. But if you're doing quantitative thermography, so you're actually measuring, if you're going to start stating measurements, then starting with a calibrated camera is not a bad place to start. And also, but it's much more than that, because even a £25,000 camera is normally only calibrated, specified, plus or minus 2 degrees C. So we're looking for very small temperature differences in buildings. And if you start building up, let's say, error bars on accuracy of measurement, you're going to start doubting you can do anything with a camera. So you have to understand what's going on and the limitations, and calibration isn't necessarily a primary limitation. Setting up the camera absolutely is important, and I could probably spend about 3 days training you on how to set up and use a camera. There are some basic principles that are important to know that will make your life an awful lot simpler and allow you to be quicker and more efficient on site. But remember, if you take images in the right way and you can be trained on how to take images in the right way. If you get the important things right when you take an image, you can change almost all the other settings on the camera later in software. So if there's always going to be a trade-off between spending time on site, getting the perfect setup in the camera, and going hell for leather on site, grabbing the data as fast as you can before the sun comes up and ruins everything you're looking at, and then knowing how to take that data away and make the necessary adjustments and changes to take your radiation data into measurement data. So I don't know if that's an overly long answer, but there's a lot in that question. I don't know if that's helpful.
Thanks very much, Mark.
But to boil it down, if you spend £300 on a camera and you're going to wander around just checking ceiling insulation, is it there or isn't it? I wouldn't spend £1,000 a year on getting a calibration done. I hope that's helpful.
Okay, thank you. I can remember range, focus, context, contrast. Those are the things that I nearly.
Range,
it was a few years. It was pre-COVID, wasn't it? So
range, focus, and composition.
There we go. Yeah. I never was a perfect student. So Laura also asked, what are the specific issues around windows and glass? You know, does taking the image at an angle affect the outcome?
I can probably guess who this Laura is. Yes, angle is very important. Yes, is the answer. Is incredibly important for windows. When I was talking about elevation earlier, some people call it the third floor effect or the sixth floor effect, or if anyone on the call has done some building thermography, I'm sure many of you have, and you've looked at the building, if you're standing outside looking at a tall building, and as you look up the building, you start seeing windows typically, but often other parts of the building, changing temperature the higher you look up the building. That is often to do with viewing angle and not to do with anything to do with the building. And so, yeah, that's a very important factor. And the problem with glass is that although, again, for any of you that have done a level 1 or level 2 and you know what emissivity is, although glass is actually quite high emissivity, it behaves quite oddly in the long wave infrared spectrum that all normal, and not all, but all building cameras use, and it suffers from something called specular reflections, and so it can be quite complex looking at glass. There's some things you can do in some cases, but you have to be very aware of the limitations of infrared on windows and on some UPVC actually is a slightly strange material in my experience. I don't know if I'm talking from a basis of scientific fact, but from experience, I've seen some pretty funny things on UPVC frames as well. But yeah.
And that leads straight into the next question, which is, to what extent does the color of the material influence infrared? Do you calibrate for this? And for example, you know, would a white wall radiate less heat than a black wall? So in terms of the emissivity and reflectance.
So if you've got a black painted wall and a white painted wall, and the paint has got identical composition, then no, color makes no difference. If they are the same temperature, the camera will tell you they're the same temperature. You won't be able to see which bits are black and which bits are white. However, the real world's a bit different from that, because the white wall and the black wall might have absorbed different amounts of energy across different parts of the spectrum, and therefore might actually be a different temperature. And so then you're going, now what? Again, this is where it starts getting hard. So the short answer is no, color is irrelevant. It's not quite that simple. But
Okay.
the answer is no, color is irrelevant.
And Mick, who's a client of a passive house building, says, can you tell building makeup? So if there's a solid brick wall or a cavity and its depth, so that goes back to your earlier point about it doesn't see through walls, but are there any circumstances where, beyond that grade 2 listed timber frame building, where you get an indication of what you're looking at, the construction type?
Yes, I mean, so depth, no. It is fundamentally a two-dimensional technology. So depth is a third dimension, and the answer is no, you can't. If the depth has, again, the short answer is no, you can't see depth. Yes, you can in many cases, if you set up the right conditions and or find the right conditions. You can often learn a lot about the construction. So is the render delaminating? Is the insulation continuous? Is the, do I have dot and dab or wet plastered wall when I can't get to it and go and tap on it, for example? Yeah, there's a lot you can find if you know what you're looking for and you think through the physics of what's going on. Well, the sun's been shining on it and da-di-da-di-da, whatever it might be. So again, short answer is no, you can't get depth. Yes, in many cases you can get a lot of valuable information on structure.
Yeah, and one of the people watching, who has a digital name rather than a name, says they tried to use it to get to the bottom of why customers are finding that their new build homes are cold, and they're recognizing that lots of insulation isn't installed correctly, which is what you've highlighted in some of the cases that you've shown us in the case studies. So there are three more fairly chunky questions that I just want to try and make time for. So the first one is from John. On the slides showing the passive house, can you explain why you interpreted the cold spots as air leakage? Because they looked like they were over cold bridging materials like steels. And it would be interesting to see thermographic images, for example, of Intello air-sealed buildings. Intello is an air tightness membrane for anyone who hasn't used it before. But what were the specific things that you saw in the images that made you think it was air leakage?
Well, in that particular case, so number one, for those of you who know him, which probably be quite a few, Mr. Jennings was there probably at about -75 PA, I imagine at that point, although I don't tend to go quite as aggressively. So there was a lot of depressurization. Point number two, on the image I showed you, in my mind, I can remember there was clearly air leakage around the door. And this was a house that it was a passive house with a timber frame. And the big problem, I was working for a firm of consultants who are acting as experts. It was a dispute on a very expensive house. So I provided my information. I wasn't involved beyond there. But the crux of the problem was the timber frame had moved and the passive house wasn't very passive anymore. So there were areas, I don't know if the particular image you were looking at from my memory, that there were areas where I could see thermal bypass, which may not have been actual air infiltration, but there were I know there were places where you could feel it.
Yeah, yeah.
You could feel it. The place was drafty.
So it's a combination. It's actually not just the infrared with air leakage that strong, especially in a depressurized situation. You can actually feel it, can't you?
Yeah, I mean, thermal imaging it's just a tool like anyone, anyone who uses, anyone who does building diagnostics and looks at building pathology, everything's a toolkit. Okay, the center of my toolkit's thermal imaging, but your moisture meters, your nose, your eyes, your salts testing, your air testing, your everything else, it's all part of a suite of tools that allow you to understand a building fabric.
So we're just about to trip over time, but I'm going to carry on with the questions because we still have a significant number of people in the event. So I'll carry on and see if I can do justice to the rest. So does the building thermography course equate to level 1 training, or how is it different? So what do the qualifications mean? So that might be a question that you can answer very briefly now, but yeah. I would suggest perhaps Glowlow gets in touch with Mark independently.
So in short, the ScanTherm training is not third-party accredited, and I don't claim it is. The problem is that there isn't a meaningful syllabus for a training course that exists now. There have been attempts at them, but they're flawed, in my opinion. And so the ScanTherm training is, I would say, as good or as bad as you want it to be, because there isn't a meaningful syllabus to certify it to. So it covers about, and I think on the certification it says, I think it actually, I certify personally, or I ScanTherm certify personally, it covers about 16 hours of the syllabus of a level 1, because we cover theory, but we cover what you might spend 16 hours on level 1, we probably spend a morning on. Of the 3 days, it's intensive. Anyone who's been on it says it should have been a 4 or 5 day course. But by the way, it was nice not losing 5 days at work, so I understand why it was 3 day. So I don't claim it to be an alternative to level 1 or level 2, because it isn't. It's better if you want to do building thermography. If you want to tell someone you have an internationally recognized thermography certification, it's worse because it's not an internationally recognized thermography certification. And if you actually look at the title of the ISO 18436 Part 7, which is the ISO standard called out level 2 for BREEAM, it's about thermography of machines.
Yeah, okay. So you're actually in a position where it's more relevant to some of the things
so
that some of us.
That's why this was developed, because there was nothing that taught you how to not go and make a fool of yourself doing.
I think in this sector in sustainable construction, we all understand the gaps in the available training, which is actually why Lucy set Green Register up in the first place. Yeah. So Lydia says, if you do want to do quantitative measurements, which temperature do you consider in calculations? The surface one, i.e. the one from the thermal image, or the reflected one? So if you choose the reflected one, how do you establish or calculate the reflected temperature value? Okay, so I'll see if you can interpret what that means, and if not, we'll ask her to.
Yeah, I think I understand what it's saying. So if you're doing quantitative assessment, which I think was the question, so you're going to measure absolute temperatures within the specifications of the equipment you're going to use. Absolutely, you have to understand the background, or the reflected, or T-reflect, or whatever else you want to call it. So you have to either measure it. How do you measure it? There's 2 different methods, but the common method is using what I call a rat board, and the person who asked the question, I think, will know what a rat board is. So you have to use a rat board. In some circumstances, you can make very reasonable approximations of it, but in every case, whether it's qualitative or quantitative, you have to think about, you have to consider background temperatures. They are a fundamental parameter in any building thermography. So if you're doing wholly quantitative, external thermography in particular, you still have to be thinking background temperature, because background temperature ultimately, and I suspect the person that asked the question knows this, actually affects the temperature of the wall. So, so not only is it a parameter you need to measure the temperature of the wall, it's a parameter you need to temperature. You need to, because the background temperature is changing by the minute. And that means the wall surface temperature you're looking at is actually going to be changing potentially by the minute. And this is where it gets harder. And we cover that stuff, which you don't cover properly in level 1 or level 2 about buildings. We cover it properly. You go away from this course really or you should do, really understanding background temperature.
Okay, 2 more points very quickly. I appreciate everyone's staying a little bit longer. So Aaron is obviously using some of this, or hoping to be using some of this technology. What temperature margin do you use between the minimum and the maximum settings on nighttime winter fabric inspection?
Okay. So I think you said, and Julia, pick me up if I misheard, what temperature difference are you looking between the internal air temperature of a heated building and the external air temperature on a cold night? Is that the question?
Aaron, is that right? Do you want to quickly unmute yourself and just help Mark understand your question?
Oh, I haven't heard an answer.
No, I haven't either.
Sometimes
it takes a wee while, doesn't it, to unmute. Hi, Aaron.
What I was thinking, the maximum and minimum temperature setting on the camera, just to highlight where the heat loss is coming from, because sometimes if you use the auto temperature setting on my the small compact camera, it's not obvious, so you have to change the settings a bit.
Okay. And I understand the question. So no, it wasn't what I said. So I'm going to answer the question you didn't answer, but I just suppose because someone's going to ask it, I'm sure. When you do a heat loss survey, the magic number everyone always quotes, and probably most people on the talk have heard of, you need a delta T, a temperature difference, in this case of air from inside to out, heated building to outside of 10 degrees. That's what the standard says. So if you're going to comply with the standard, you need a minimum of 10. The shorter answer is, what do you need? I'd say as big as possible. And the other answer is, can you get away with less than 10? And the answer is, it depends. But 10 is the magic number that's in most good practice guides. Aaron was actually asking a different question. And what he was asking about is, basically what he was asking is, how do I get my thermal camera under control? And there's a number, there's not a magic number on how you get your camera under control. It depends on the circumstances. So I can't give you an answer to that. But when you know more about building thermography, you'll be able to work out a good guide for what that number might be. Again, there isn't a magic number, and it depends what kind of kit you've got, and it depends on a whole load of other settings you use in the camera. But you're on the right lines by working out that cameras don't just get used in auto. So well done on that. Yeah.
And then the last point I'm going to give to Mike Andrews, who seems to be quite experienced. Hi there, Mike, from First Thermal. And he's saying that he's finding that in new homes, dot and dab plastering allows cold air to flow down behind the dry lining plasterboard. And it only shows up with pressure reduction. So when we're depressurizing and having thermography at the same time, and he's using that technique, as am I. And just is recognizing that it's a national scandal, and Diane Hubbard also agrees. And it's exactly the situation I've got in my house. You know, dot and dab plasterboarding. It's a builder's dream and everybody else's nightmare. That's I bet you found a lot of projects like that, Mike.
I would add to that it's incorrectly installed dot and dab dry lining, because if you go to British Gypsum website and see how you're supposed to do it. If you're trained in college, they say you should put a border of adhesive around each board. And they don't do it because nobody sees it. It uses more material, it takes longer, and you know, it's out of sight.
Yes.
And it's a disaster. And we did thermography on a house, and it was present both upstairs and downstairs. They couldn't heat the house. It cost 350,000 on the outskirts of Bristol. And opposite it was the parking place for the National House Building Council building inspector.
Yeah. No, it's
sheer money grabbing incompetence.
I totally agree. It's a national disgrace. And what the only thing I would add is you can often get a hint of it without let's say a blower door, because there'll be high and low pressure areas around the house in various places. So you can often get a hint of it. But the example I think I showed earlier shows how a hint turns into a disaster zone, and it's absolutely commonplace. And it's not only the perimeter of the plasterboard, it's any penetration. So you know, the windows, the wall sockets, the switches. You know, the number of times I've gone round and you go to turn a light on, and before you get your hand even near the light switch, you can feel the draft pouring out. You know, before you even.
Absolutely.
Couldn't agree more.
Yeah.
So,
can I chip in one other thing?
Oh, go on, please do, Mike. I'm just going to unashamedly advertise some events.
Today on the news, they announced that a small satellite had been launched called HotSat, which was going to show the houses that needed retrofitting from the sky, because it could show up the temperature loss. Now, somebody did a PhD on this about 10 years ago and showed that it was an impossible way of showing which houses had the most temperature loss. Yes, for things like damp, as we've seen, but if you want to view, you know, from above, if you want to look at temperature loss, don't do it from the sky.
Yeah, sorry, Julia, do you want me to speak to that?
Yes, please do. Yeah, I'm going to leave that slide up and people can read it at their leisure.
Okay, I'll try and be very brief. I don't know the one, or I'm not sure I know the one you mentioned today, but there's another company that's launching a suite of satellites, making lots of noise, lots of investment, I think public. I posted a comment on LinkedIn, and I haven't looked at it. I don't think anyone picked up on it. I would say you don't need a PhD to work out the level of error. And so what the company that I've looked very closely at, because they actually approached me to do an aerial survey of Leeds, and if anyone knows what IFOV was, they were looking for an IFOV of I think I worked it out as 3 meters. Another way of saying that is a pixel is 3 meters. So, and their publicity, and unfortunately I can't remember the organization in Leeds that was working with them to get this thermal map. Every dot is the size of a house. Point number one. Point number two, well, I could just go on. Where do I go on? How do you know which house was heated, which one wasn't? Point number three, how do you know what the roof material is and which angle it was? Point number four, were you measuring background temperature? Point number five, it goes on. So it's, I think satellite thermography has got some really good uses, and I'd love to be involved in it and talk to people about it. Go and look at outflows in rivers and and sewage into seas and lots of great things. But looking at individual houses, no.
Grand. So there we are. We are nearly at 6:15. So thank you very much for hanging on. It's clearly a very exciting and interesting subject, and you've covered it in a tiny snapshot in such good detail, Mark. Thank you very much. Thank you all of you for joining us this evening, and please do go on the website and have a look at some of our other events. You will receive a feedback form and a copy of the presentation and the chat. So if there are any comments in there that you want to remember, don't worry too much. We'll send them on to you. And have a very good evening. Thank you very much. Stay cool.
Thanks, Julie.
Thank you. Bye.
Thank you.